Hello, good morning. Am I audible? Audible? Hello. Hello, am I audible?
Yes, sir.
Okay, in the last class, we have discussed this problem, I hope. So here, 26 kilonewton force is the resultant of the two forces, one of which is shown. So here you have basically two forces. One is 10 kilonewton. The other one, you don't know the magnitude and the direction with respect to the horizontal axis, but the resultant of these two forces is 26 kilonewton, so which is making an angle theta in one with respect to the horizontal axis. So we need to find the other force. So now let us say, let P be the unknown force which makes an angle theta with the horizontal. Now here instead of theta 1 and theta 2, the slope of the line is given. So by using tan relation, you can get these angles. That is theta 1 is 67.38 and theta 2 is 36.87. So in any problem, if the angle is not given, if the slope of the line is given, directly you can find out the value of theta by using the tan relation. Now here, so sigma f of x, that is sum of the horizontal component, should be equal to the horizontal component of the resultant, that is sigma. Here the resultant is not acting along x-axis or y-axis, correct? It is making an angle of theta 1 with respect to the x-axis. So hence sigma f of x should be equal to the horizontal component of the resultant. So in our case it is, so we have assumed a force here P. So let us say you have a force P, so which makes an angle theta. So P cos theta, if you resolve it along horizontal direction, so it will be P cos theta plus you have 10 cos 36.87. This is the angle theta 2. So 10 cos 36.87 is equal to, that is the horizontal component of the resultant. If you resolve the resultant along horizontal direction, its Rx component is 26 cos 67.38. So thereby we will get the value of P cos theta. That will be equal to 2. Now similarly, sigma f of y should be equal to the vertical component of the resultant. So again, P sin theta is the unknown force and its angle is not known, plus if you resolve this, it is 10 sine 36.87, 10 sine 36.86 is equal to the resultant vertical component is 26 sine 67.38. So thereby we'll get the value of P sin theta. It works out to be 18. So dividing the equation 1 and 2, so P sin theta by P cos theta, P goes off. So 18 by 2, so tan theta is equal to 9. So theta works out to be 83.66. So here it means the force P is acting somewhere here, nearing to the vertical axis, because the angle being about 83.66. And now squaring the equation 1 and 2, or else you have any one equation, that is P sin theta is equal to any one equation, you can substitute the value of theta, thereby you'll get the value of P. So these types of problems you may have in the examination. So one force will be given and the resultant force will be given, and you need to find the magnitude and direction of the other force. So we shall proceed with the next problem. So here the resultant of a force system on the bracket, so it's a bracket as shown in figure, is acting vertically upwards. So in this case, the resultant is acting vertically upwards. So hence sigma f of y is equal to r and sigma f of x should be equal to 0 because the resultant is acting along the vertical direction. So upward, if the angle 30 between the two 4 kilonewton force is fixed, now here you have two 4 kilonewton fixed and this angle is fixed. This angle is fixed. Find the angle theta, also determine the magnitude of the resultant. So here, since the resultant is acting along y-axis, you need to find only the magnitude of the resultant. Hence, sigma f of y should be equal to the resultant, and sigma f of x should be 0 because the resultant is acting along y-axis. Now we shall proceed with the problem. So here you have three forces. This angle is fixed, and you have one more force in the second quadrant, 2 kilonewton, which makes an angle 60 degree with respect to the horizontal axis, and this angle you need to find. So now sigma f of x is equal to Rx. That means the sum of the horizontal components should be equal to the 0 because Rx is also 0 since the resultant is acting along the y-axis, and hence sigma f of y is equal to r by that is equal to r. Hence sigma f of x should be equal to 0. So now we shall find the sum of the horizontal components and equate it to 0. So if you resolve this, its horizontal component is 4 cos theta, plus if you resolve this one with respect to horizontal, it is 4 cos 30 plus theta, 4 cos 30 plus theta, and minus 2 cos 60, minus 2 cos 60. So this is equal to 0. So 4 cos theta plus 4 cos 30 plus theta. So you take it on to the other side. So cos theta plus cos 30 plus theta is 1 by 4, and cos theta. So this is nothing but you have to use cos A plus B formula. That is cos A cos B minus sin A sin B. So thereby on simplification, we'll get the value of theta as 67.57 degree. So now sigma f of y, the sigma f of y value should be equal to the value of the resultant. So we need to find the magnitude of the resultant. So in this problem, the resultant is acting along vertical axis, but its magnitude is not known. So hence sigma f of y should be equal to the value of the resultant. So that is sigma f of y is r is equal to sigma f of y. Now, so we know this angle. We know this angle now. That is 4 sine. That is the angle is I think 67.57. 67.57. So 4 sine 67.57 plus 4 sine 30 plus 67.57. 30 plus 67.57. It works out to be 97.57 plus 2 sine 60. Because if the vertical component of this 2 kilonewton forces, that is 2 sine 60. So that should be equal to the value of the resultant. So we get the value of the resultant as 9.394 kilonewton. So always you have to write the appropriate unit against the answer. So if you write merely 9.394, it doesn't carry any meaning. So always, as soon as you arrive at an answer, you write the appropriate unit, whether it is in Newton or kilonewton. So any doubts with this problem? So here you have to use some mathematical equation, that is cos A plus B formula. So thereby you get the angle, and also you can find the magnitude of the result. So next we shall move on to the next problem. 4 forces acting on a block, acting on a hook. So it is in the form of a hook as shown in figure. Determine the direction of the force 150. That is this angle you need to find, such that the hook is pulled in the x direction. So determine the resultant force in the x direction. That means here the hook is pulled in the x direction means the resultant acts along the x direction. The resultant acts along the x direction. Hence the sum of its components along the y direction becomes 0. So we can go through this problem. 4 forces acting on a hook are shown in figure. Determine the direction of the force 150. That means you need to find this angle such that the hook is pulled in the x direction. It is pulled in the x direction. So determine the resultant force in the x direction. You need to find the magnitude of the resultant also. The magnitude of the resultant also. Now let us put these two conditions. That is sigma f of x should be equal to the resultant, since the resultant is acting along x direction, and hence sigma f of y is obviously 0. So now we shall find out sigma f of y should be 0. It is 1 by 1 we shall deal. So this force, so always select the reference axis first. So if you resolve this force, its vertical component is minus 80 sine 45, minus 80 sine 45 plus 60 sine 60 So this is 60 sine 60 plus you have this 100, correct? 100. So this makes an angle 30 degree. So 100 sine 30. So always be careful. So look out the angle of this force with respect to, don't write 100. This is 30, correct? 100 Newton force, it's making an angle 30, hence its vertical component is 100 sine 30 plus 150 sine theta, 150 sine theta. So this should be equal to 0. So 150 sine theta is equal to 45.39. So you take it on to the other side. So hence you will get the value of theta as 17.61 degrees. Now we need to find the magnitude of the resultant, hence sigma f of x should be equal to r. So again, you have to find the sum of the horizontal components along x direction. So if you resolve this force, it is 80 cos 45. Next, if you resolve this force, it is 150 cos theta, you have got 150 cos 17.67. And if you resolve this force, it is 100 cos 30 acting in the positive direction. And this is this 60. 60 is 30 plus 30. That is 60 cos 30. 60 cos 60. 60 cos 60. So thereby you get the magnitude of the resultant. So it's a very simple problem. Only thing is you need to go through the problem and understand the problem and find out whether the resultant is acting along x direction or y direction. So thereby putting these conditions, you can find the unknown angle and also the magnitude of the resultant. So again, one more problem you have here. So a force, 4 forces acting on a bolt as shown in figure determine the magnitude and direction of the resultant force. So here the either resultant is not acting along x direction or y direction. So now here you have a 4 forces. One is acting along y direction, it is 100 kilonewton force. The other force is acting along the x direction, 250 kilonewton force. And here you have a force of 200 Newton. So the slope of the line is given 2/3. And here one more force is acting in the 4th quadrant, so which makes an angle 30 degree. So we need to find the magnitude and direction of the resultant. So first, the sum of the horizontal components. First you need to find this angle. So 2/3. So 2/3 is tan 2/3. You can find this angle. So here he has not done, it's directly taken. So you can find by using the tan relation this angle. So first you select the reference axis x and y, x and y. Then you find the sum of the horizontal component sigma f of x. So here along x direction you have a force of 250 Newton. So 250 cos 0, or you can just write 250 plus you have this force. Its horizontal component is 300 cos 30, 300 cos 30, and 200 cos 33.67. So tan theta, theta is tan inverse 2/3. So this angle is 33.69. So thereby you will get the magnitude of the result. The algebraic sum of the horizontal component. So here, what you observe here the units are not written. Correct? Here the units are not written. So against the answer, you write kilonewton. So maybe due to the printing mistake. And similarly, you find out the value of sigma f of y. So sigma f of y, 100 acting in the upward direction, plus this one, 300 minus 300 sine 30, minus 300 sine 30, plus 200 sine 33.67. So it works out to be 60.939 kilonewton. So once you get the sum of the horizontal and vertical components, you can find out the magnitude of the resultant. It works out to be 678.958 kilonewton. So then you can find the direction. So the procedure is same. In a very concurrent force system problem, you need to find either the magnitude of the resultant and also the direction of the resultant. And in some cases, the resultant may be acting along x direction or y direction. You may need to find the magnitude and direction of an unknown force in such a case, or sometimes the value of the resultant will be given. So like this, you may have many problems, but only you have to follow the procedure. So in always in a concurrent force system, first select the reference axis x and y, about which you are going to find the sum of horizontal components as well as the vertical components. So once you find the sum of the horizontal and vertical components, then by using the expression r is equal to square root of sigma f of x square and f of y square, you can find the magnitude of the resultant. Once you find the magnitude of the resultant, you can find the direction of the resultant. And now one more typical problem here. You have two forces, 800 Newton plus 600 Newton acting at a point as shown in figure. The resultant of the two forces is 1200 Newton. The value of the resultant is given here. Determine the angle between the forces and direction of the resultant. So here the resultant value is given to you, that is 1200 Newton, and you don't know the angle between these two forces. So this angle you need to find, theta. So you have two forces acting at a point, one is 800, the other one is 600 Newton, and this angle you need to find. And also you need to find the direction of the resultant, theta or alpha. That alpha of the resultant, that is tan alpha, is equal to sigma f of y by sigma f of x. Now this is the force. Now first select the reference axis along vertical and horizontal direction. Now if you resolve this forces, that is sigma f of x. Sigma f of x is, in our case, you have only this one, correct? It may be 800 sine theta, correct? Either it may be 800 sine theta or it may be 800 cos 90 plus theta, correct? Cos 90 minus theta. So either it can be cos 800 cos 90 minus theta, or it may be either 800 sine theta. And sigma f of y, that is 600 plus 800 cos theta, 800 cos theta, or it can be 600 plus 800 sine 90 minus theta. So either you can resolve with respect to horizontal axis or vertical axis. So now r is equal to square root of sigma f of x square plus f of y square, but you know the value of the resultant, that is 1200. So now let us go to the solution. You can see sigma f of x is equal to 800 sine theta, that is the horizontal component, and sigma f of y is 600 plus 800 cos theta, 800 cos theta. So you know r is equal to sigma f of x square plus f of y square. So that is squaring on both sides. Squaring on both sides, that is 1200 square is equal to 800 square plus sine square theta plus 600 square plus 800 square cos square theta plus 800 into 600 cos theta. So sine square theta and cos square theta becomes 1. So thereby if you solve this equation, you will get the value of theta as 62.72. So this angle will get it as 62.87. So then you can find sigma f of x. Sigma f of x is, that is either you can use the equation this one in order to find the direction of the resultant. Either you can use this equation or you can substitute, you can find out the values of sigma f of x. 800 sine theta, so theta you have calculated, you will get some value. Similarly, you can find out sigma f of y, that is 600 plus 800 cos 62.87, will get some value. Then you can find tan alpha. Tan alpha is equal to sigma f of y by sigma f of y by sigma f of x, or else you can also use this equation. So this we have discussed in the law of parallelogram of forces, how to find the magnitude of the resultant, that is q sine theta divided by p plus q cos theta. You can call these forces as p and q, or else you can find sigma f of x and sigma f of y. Then you can find out the value of the direction of the resultant, that is tan alpha, or here he has taken it as tan phi, whatever it may be. So it works out to be about 36.34 degrees with respect to the vertical axis. And the direction of the resultant with respect to the horizontal axis is 90 minus 36.34. So it happens to be 53.66, because here this angle has been formed with respect to the vertical axis. Hence the resultant direction is also with respect to vertical axis. The tan phi works out to be about some 36.34. So you can also find the direction of the resultant with respect to the horizontal axis. Now, so far we have discussed so many problems on concurrent force system. So wherein so many forces are acting at a point and it is making an angle of inclination either with respect to x-axis or y-axis, and in some of the cases the angle is not given, the slope of the line will be given, and in some of the problems we have discussed where we know the magnitude of the resultant. So in such a case we need to find the direction of the resultant, or in some cases the resultant may be acting along x direction or it may be acting along y direction. In such a case we know how to put the conditions, that is sigma f of x is equal to r and sigma f of y is equal to 0, or the other way, if the resultant is acting along vertical direction, then sigma f of y is equal to r and sigma f of x is equal to 0. So these types of problems already we have discussed. So next, let us move on to a problem. So here a body of mass 600 Newton, a body of mass 600 Newton or a weight of 600 Newton is resting on an inclined plane. You can see here, this is an inclined plane. So this inclined plane is making an angle 45 degree with respect to the horizontal axis. It is making an angle 45 degree with respect to horizontal axis. And here you have a block of weight 600 Newton, block of weight 600 Newton, and it is subjected to a force of 700 Newton, which makes an angle 30 degree with respect to horizontal axis. So in this problem, it is an inclined plane problem where you have a body resting on an inclined plane and it is subjected to the forces. You need to find the magnitude and direction of the resultant. So whenever you have a problem on inclined plane, it is always better to select the reference axis, x and y axis, parallel and perpendicular to the inclined plane. So I could have selected the reference axis like this. I could have selected the reference axis like this, x axis like this, and y axis like this. So the selection of the reference axis becomes a very important role, because if you select the reference axis in a particular way such that most of the forces act along those axes, hence the resolution part becomes simple. So in our case, in this case, the horizontal axis has been considered parallel to the inclined plane. You can see that this is the inclined plane. The horizontal axis is taken parallel to the inclined plane and the vertical axis is perpendicular to the inclined plane. Now here, the weight of the block acting vertically downwards, and you have a force of 700 Newton acting on the block, which makes an angle 30 degree with respect to the horizontal axis. Now it is a concurrent force system. It is a concurrent force system. Now you need to find the magnitude as well as the direction of the resultant. Now here I think you have one more force. That is 800 Newton. 800 Newton force is also acting along y direction. Now, so first, so if this is 45 degree, if this is 45 degree, obviously this angle is also 45 degree. So how it is 45 degree? Anyone? So Likit Kumar.
Yes, sir.
So how this is 45 degree? So now you can see here, if I draw a line, if I draw a horizontal line over here, so this line will be essentially parallel to this line, correct? This line will be parallel. If I draw a horizontal line like this, then this angle is how much? Total angle from this point to this point, it is 90 degree, correct? It is 90 degree. So here, this is the x-axis. So this angle is how much? 90. This angle is how much? It is 90. Hence, this is also 45. This is also 45. And this angle, the angle between the 600 Newton force and the x-axis, this is also 45 degree. So in an inclined problem, so I have some problem with my throat. So anyway, I will continue in the next class because I am running out a bad throat. So I request all of you to mark the attendance in the chat box. So anyway, you please mark your attendance. Now we shall find the sum of horizontal and vertical components of this figure. So now sigma f of x, sigma f of x. Now you can see here this force, correct? If I write a separate figure, that is, this is x-axis, sorry, this is y-axis, and this is x-axis. If I write a separate figure, so this force is acting at this point, and this angle is 45 degree, and this angle is also 45 degree. And here you have a 700 Newton force, which makes an angle 30 degree with respect to horizontal. Now, sigma f of x, sigma f of x is equal to 700 cos 30. So if you resolve this force, it's horizontal. So unmute ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾರೋ ಮಾತಾಡ್ತಿದ್ದಾರೆ. ಕೆ ಆನಿ. Now we shall find sigma f of x, sigma f of x. So it is, now you can see this force. You can see the direction of this force. So this force is acting in the fourth quadrant, correct? You can see the sense of the arrow. This force is acting in the fourth quadrant. And if you resolve this force, its x component is plus 700 cos 30, plus 700 cos 30. And if you separate this force and write a separate figure, so this force is directed towards the third quadrant. This force is directed towards the third quadrant. And if you resolve this force, this angle is also 45 degree. It is minus 600 cos 45. So sigma f of x is equal to 700 cos 30, 700 cos 30 in the positive direction, because in the fourth quadrant sigma f of x is positive and sigma f of y is negative. Whereas in the third quadrant, sigma f of x is negative and sigma f of y is also negative. So hence, sigma f of x is equal to 700 cos 30 minus 600 cos 45, or it can be minus 600 sin 45. Both are sin. Minus 600 sin 45. And sigma f of y, sigma f of y will be 800, correct? 800 is acting along the upward direction. 800 minus 700 sin 30 minus 700 sin 30 minus 600 sin 45. 600 sin 45. Now just look at the answer. Now you can see here sigma f of x 700 cos 30. So if you resolve this force, its x component is in the positive direction, 700 cos 30. And if you resolve this, it is either minus 600 sin 45, minus either 600 sin 45 or either 600 cos 45 is equal to 181.953 Newton. And similarly, sigma f of y 800 minus 600 sin 45 or 600 cos 45. Okay, you mark the attendance in the chat box. So I'll continue the class on Saturday. You have my class at 10:45 on Saturday. So we shall meet on Saturday. So ಯಾರಾದರೂ ವ್ಯಾಕ್ಸಿನೇಷನ್ಸ್ ತಗೊಂಡ್ರಾ? ನೀವೆಲ್ಲ ನಿಮ್ಮಲ್ಲಿ ಯಾರಾದರೂ ಫಸ್ಟ್ ಡೋಸ್ ಆಫ್ ವ್ಯಾಕ್ಸಿನೇಷನ್ ಯಾರಾದರೂ ತಗೊಂಡಿದ್ದೀರಾ?
Yes, sir.
Okay, how many of you have taken in this class? Obrena? Somebody said yes, sir. I don't know who it is. ಬಾಕಿಯವ್ರದ್ದೆಲ್ಲ ಆಗಿಲ್ವಾ? ಸ್ಲಾಟ್ ಸಿಕ್ಕಿಲ್ವಾ ನಿಮಗೆ? ಹಲೋ, okay, anyway, I'll be ending the session, ending the class. So thank you so much. Have a nice day. Stay safe. We shall meet on Saturday. Till then, goodbye.
Thank you, sir.